This video explains when to use scatter plots and how to create and interpret a basic scatter plot for two variables. Scatter plots are useful for uncovering and illustrating the relationship between two numeric variables. By the end of this video, you should be comfortable not only with creating scatter plots, but also with labeling your data points. In this video, we will use the data for two variables. One variable is the city mileage, and the second variable is highway mileage. The first variable displays the miles per gallon in the city, and the second variable captures the miles per gallon on the highway for the top 10 best-selling cars in 2017 based on Kelley Blue Book. The data source for these variables is in the textbook. The question that we can explore with a scatter plot can be formulated as follows. Do cars that have high gas mileage in the city also have high mileage on the highway? If the answer is yes, we should find the two variables be positively associated with each other. The first step is to create an R code chunk in the R Markdown file. To do this, we click Code, Insert Chunk. Once you have done this, you can see an empty R code chunk in your RMD file. You will write the R code in this R code chunk to create a scatter plot. The second step is to create your data. Inside the R code chunk, we will create first three variables: city mileage, highway mileage, and car brand, which we title names. We can do it using the C function and the assignment symbol. Thus, the first comment line explains that the next three lines of our code will create three variables. The three variables created with the raw data are called city, highway, and names, respectively. The city variable contains the data on miles per gallon in the city for different car brands. The highway variable contains the data on miles per gallon on the highway for different car brands. And the names variable contains the names of the 10 car models. All these data, all these numbers come from this original data set. The third step is to enter the R code for the scatter plot using the plot function that we explain in the next comment line. Note that inside this plot function, we list the variable city first so that it is represented on the x-axis, and then list highway variable so that it is represented on the y-axis. We use the main option, which is city MPG versus highway MPG for top 10 best-selling cars in 2017 to add a title to the graph. We use two more options, XLab and YLab, to define the labels for the x and y axis. In this case, the x-axis is labeled city MPG and the y-axis is labeled highway MPG. Running this code, next, we click on the icon Run Current Code chunk, which produces the scatter plot that is titled City MPG against versus the Highway MPG for top 10 best-selling cars in 2017. It tracks the City MPG on the x-axis and Highway MPG on the y-axis. The x-axis on the scatter plot has the values that range from 15 to 30 in intervals of 5. The y-axis, that is labeled Highway MPG, has the values that range from 25 to 35 in intervals of 5. The scatter plot shows a clear positive correlation between the two variables, city MPG and highway MPG, which means that higher city mileages are associated with higher highway mileages. Note two interesting things about this figure. First, there are 10 cars, but only 9 data point symbols. This is because Ford F-Series and Chevy Silverado have identical values on both variables and overlay on the same symbol. Second, What isn't immediately clear from looking at the figure is which data points correspond to which car models. To help fix this problem, you can add text labels to each of the data points. For this, we will return back to the R code chunk and slightly modify it by adding labels to data points. To do this, we can use the text function. Inside the text function, first list the x-axis variable, which is city, and then the y-axis variable, which is highway. This provides the coordinates for the data points in the scatter plot. Then list the labels option, which takes the text values of the variable entered. In this case, this variable is called names. And then place those text values near corresponding data point coordinates. The pause option specifies the position of the text value near a data point, and when one is chosen for pause, as you see in this video, it means that the text will appear below a data point. If we would have chosen 2, then the text would have appeared to the left of a data point, whereas if we'd chosen 3, then the text would appear above a data point, and with 4, the text would have appeared to the right of a data point. However, we chose 1 instead of 2, 3, or 4 to make sure that the text will appear below a data point. The next option specifies how the text value should be scaled relative to the default value of 1, with 0.4 being 40% smaller. The offset option is used with pause option. So the offset option determines the distance of the text label from the specified data point coordinate in fractions of a character width. The smaller the value, the closer they are. This completes the modification of this R code chunk, and next we need to run the R code chunk. The new updated scatter plot now shows not only the city MPG versus the highway MPG for the top best-selling car models in 2017, but also the labels for each data point on the graph. Now the labeling helps us to see that there are 10 car models compared in this scatter plot. The next step is to interpret the scatter plot, which can be done as follows. This scatter plot demonstrates a positive correlation between the two variables, city MPG and highway MPG. The higher a car's miles per gallon in the city, the higher that car's miles per gallon is on the highway. This is not a surprising result. With text labels for the data points, the scatter plot provides a much easier way to compare the 10 models. Honda Civic is far ahead of the other 9 in both city and highway miles MPG. In contrast, Ram Track has the lowest gas efficiency in terms of both city and highway MPG. This video explained when to use scatter plots and how to create and interpret a basic scatter plot for 2 variables.